We've been working pretty hard on solving equations, solving polynomial equations. We've been working on a technique called factoring, and we've explored a whole bunch of different scenarios. And we're pretty close to finishing out this whole unit. So we should have a very good understanding at this point of what should happen with each of these questions. So let's see what we got for number one. What are the solutions to number one? Start with Chris, Stephanie, and then we'll go to Matthew. Okay? Okay. The correct solutions are 1 and -1. I also want to show you what the graph of this looks like. You did not have to do this. I just want to show you what this graph's like so you can see what's coming in the near future. This is the graph of this equation. It is called a parabola. And it's hard to tell a little bit, but you can see that the parabola crosses the x-axis at two different points, here and here. And it crosses at 1 and -1. That's what solutions are. Solutions are the points where a graph crosses the x-axis. Number 2, what did you get as a solution? We'll start with Michaela, John, and then Danielle. Okay? Correct solutions are 5/2. I want to show you what the graph of this looks like so you can see what's coming in the near future. Why is there only one solution to this graph when there was 2 to the other? Well, this is a parabola, and it only crosses the x-axis in one location, at the point 2.5, 0. The solution represents the point where the graph crosses the x-axis. So when you get one solution, you're talking about a parabola that touches only once. Michaela, you got a comment or question? Go ahead. Okay? And that will be true for any parabola that has only one solution. Any polynomial equation that has only one solution. It'll be somewhere along the x-axis. It could be upside down, could be over here, could be over here. But if it has one solution, it means the vertex, this bottom point or the top point, is touching the x-axis. Chris and then John. Yep. One lesson away. Yep, you're going to learn how to actually draw these pictures. Okay? Comments, questions on either of these? No comments, no questions. Okay? What is this called? Only 3 people know? See, we're doing that whole, I think I should know this. Oh, I think I know. Chris? It's called the difference of 2 squares. You should have known it instantly. I believe I emphasized that the other day, that you need to know this instantly. Now, after we get the 50 over to the left-hand side and take out a common factor, what do we end up with in number 2? I see Feng cheating a little bit. Go ahead, Feng. Not a square of a binomial, no. Danielle? It's a perfect square trinomial. So, you guys didn't do your job between the other day and today. So I got 5 people in the room who even thought that they knew. But you were actually told that you had to know these instantly. So it's quite the opposite. So something has to change. All right, we'll talk about that more later. I'm sure you'll do better next time. All right, any other comments, questions? The title of today's lesson is Factoring Polynomials Completely, and it's the final section in this chapter. We have studied a lot of different ideas, some pretty complex ideas in this chapter. We're going to tie it all together finally. We're also going to add one more idea, so there is also going to be a lot going on today. So you got to put your brain in the highest gear possible. So you're going to learn a new factoring technique called grouping. And it's a technique that works when there's 4 terms. So we learned a technique at the beginning that works with 2 terms. Then we learned a technique called the trick that works with 3 terms. We learned shortcuts that work with 2 terms and shortcuts that work with 3 terms. And now we're going to learn a method that works with 4 terms. Finally, we're going to wrap everything together. And we're going to use all the different techniques to solve different equations. So, here is the sequence of techniques that we're going to be using when we finally finish everything. Okay, let me give you first the overview. I do not want you to copy. I just want you to look. To solve polynomial equations, you follow these methods in this order. The first thing you do is you check and see if there's a common factor. If there's a common factor, factor it out. That's the first thing you do every time, no matter what. Second thing, 2 and 3 are actually lumped together. We're looking for the shortcuts. Is there a difference of 2 squares? If it is, then use the pattern that you've memorized. Is it a perfect square trinomial? If it is, use the pattern that you've memorized. If you can't do this, or if you did this, or if you can't, then you go here. If you did this or you can't, you go here. If you did this or you can't, you go here. Can it be grouped? If it is, then you're going to use the method that you learned today. If you can't use any of these, then can it be factored at all? If it can be factored, then you can use the trick. If it can't be factored, then you're going to learn what to do today also. Okay? All of these are about finding the factors. Okay? So you should not have this copied yet, but you're going to see this again at the end when we tie everything together. So we're going to now learn the grouping method, and I'm going to be teaching it step by step. So the first thing we're going to do is the first thing you're looking for. I apologize, I misspoke. This is actually not the first thing you're looking for. We're going to get to the full process in a moment. But here's actually the idea behind it. What you're really going to look for after you do a couple of things with an expression is you're going to be looking for a common binomial. What that means is you're looking for a binomial that shows up more than once. So this is an unusual looking expression. Remember, we are trying to factor. So your initial gut instinct might be to, oh, I'm supposed to distribute. But that's going backwards. That's not what we want. If we distribute everything, we're going to end up with the full expression. What we want is to find the common factor. And so, guys, some of you have already lost focus. You guys got to be up here with me. This is not easy. So your eyes and brain should be able to tune into this and this. You have the same binomial showing up twice. That means that it's a common factor. Anytime a factor shows up twice, that means it's a common factor. So what happens is this is going to get factored out. The binomial gets factored out. It's the reverse distributive property. It's going to come out over here. And when we factor something out, we write it once over here to the left. So this and this gets factored out, so we're going to put it over to the left. And then what do we put next to it? We've done this before in a slightly different form. Dalton? Yeah, whatever's left. Whatever's left over will go over here. We have the 3x and we have the minus 2 left, so we do 3x minus 2. And so the common binomial factor gets written once off to the left-hand side. That's what we wanted. This is one of the steps in grouping. Any questions so far? Okay. Okay, so again, right now we're just trying to get our eyes and our brain tuned into common factors. So we're looking here and here. But that's not the same thing. It's not the same. But it's close. It would be really great if it was exactly the same. So we want to change one of them so that it turns into the other one. This is nice. This is the way we like this. But this one's not. So it would be great if we could just switch these around. But if I try to switch them around, well, the y is negative, and I would get negative y, and the 4 is positive, and I would get this. Still not the same. But there is something you can do to get it to turn into y minus 4. David? Okay. But then you have to do that. Really, you're not multiplying by negative 1. What you're going to do is factor out a negative 1. So if you say, okay, there's a negative 1 here, factor it out and bring it here. And there's a negative 1 here, factor it out and bring it over here. That will flip it around. And then the negative has to be put here. So basically what you're saying is, okay, take the negative 1 out of this and put it over here with the 3. So you have to multiply 3 times negative 1, you get negative 3, and then this flips around to y minus 4. So here's what we have. I'm going to bring this down. Y squared times y minus 4. Now we have that common factor that we were trying to identify. The y minus 4 and the y minus 4. That's the common factor that gets factored out. This is going to be brought over here. This will be brought over here. So we'll write y minus 4 as the common factor on the outside. And then on the inside, we put what's left. Y squared is left. Minus 3 is left. Y squared minus 3. You still may not have any idea what I'm talking about yet. That's okay. Because what we're doing and what I'm introducing is just the middle step. So you have to wait till you see the whole thing, and then it will start to click for you a little bit. Okay? And that's where we're at right now. So let's look at the whole thing. Okay? This is really what we're talking about. I want to factor this. So now let's go through the sequence. This is what we have to train our brain to do. We have to train our brain to do this sequence. So I'm gonna model that right now. Okay, I'm modeling it, which means that I'm talking you through what's going through in my mind, and you should be trying to understand that process to get your brain to do the same thing. Okay? So the first thing I'm going to say is there a common factor between all of them? So I'm going to look. Okay, well, there's a 5, a 2, a 5, a 2. No common number factor. There's an x, there's 3 x's, there's 2 x's, there's 1 x. Oh, but that one doesn't have an x. They do not all have a common factor, so there's nothing I can do with that first step. Step 2, is it a difference of 2 squares? Clearly not, because a difference of 2 squares has 2 terms. Is it a perfect square trinomial? Clearly not. A perfect square trinomial has 3 terms. This has 4. Can it be grouped? Yes, because your eyes should now be looking for 2 terms that look like they have a common factor. So now watch this. What if I take this one and this one and put those 2 together? And what if I take this one and put those 2 together? It's almost like we're going to do this. I'm going to write it in a strange way, and then I'm going to show you how we really write it. I'm going to take the 5x to the third, and I'm going to move this over next to it, plus 5x. And then I'm going to take the 2x squared. It's almost like I've got 2 different expressions. So if I gave you just this one, you could factor that. And if I gave you just this one, you could factor that. So now all I'm doing is saying, well, let's just do both of them. Okay? I'm going to separate them again so you can see what's going on. Okay? Let's work on the one on the left. What's the common factor that can be factored out? In other words, what's going to go like this? What's going to come over here? We've got a bunch of people who can see it. Well, 4 people who can see it. 5 people? Kayla, what do you think? Very good, Kayla. They have a 5 in common, and they have an x in common. Now, what's left? What's left? Edgar? Okay, well, Edgar, just do the first one with me. 5x times what will give me 5x to the third? Very good. X squared. Chris, 5x times what gives me 5x? 1. So I'm left with x squared plus 1. That's not new. That we did actually quite a long time ago. Does anyone have any questions about that? Okay, now let's forget about that just for a moment and come over here to the 2x squared plus 2. I want to do the same thing again. What is the common factor between the 2 of them? John?
2.
Yeah, just a 2. So watch what I'm going to do. 2, and what's left over? X-Dol? X squared plus 1. Now watch what happens when I put it all together. Now watch, I'm going to go back to example 1. We had the common factor that was a binomial here and here, and we factored it out. Now we see that again. What is the common factor here that can be factored out now? Daniela? Very good. The x squared plus 1 is what shows up twice. So this is the common factor. And so now that is going to get brought to the left. So we've got x squared plus 1. That's the common factor. And then inside, we put what's left over. What is left over? Michaela? 5x plus 2. Now, we have to check and see if we can factor any further. But we're not going to worry about that right now. I'm going to worry about that in a little while. For now, this is factored. This is a factor of this expression, and this is a factor of this expression. In fact, if we now did FOIL, guess what would happen? Dalton? It would go back to that. We can use FOIL because that's a binomial and that's a binomial. First terms, outer, inner, and last terms, boom, it would turn into that. Okay? So that's really what we did, was we did reverse FOIL with a 4-term expression. Okay? So you've only seen it done once, so give it a few minutes. We're going to do it again. The first thing is, again, to go through the sequence. I'm going to go really fast because it should be kind of obvious which one we're going to do. But here's quick. Do they have a common factor between all of them? Well, they do, and this does, but that doesn't. No variable, so no, there's no common factor. Is it a difference of 2 squares? No. Is it a perfect square trinomial? No. Can it be grouped? Possibly. What should the first group be? Remember, I'm trying to find a group of 2. What should the first group be? Ziamara? Yeah, in this case, it's this. 32x to the third minus 16x squared, because the 16 and the 32 you can clearly see have a common factor. Now we hope that the other 2 have a common factor. So here's the other 2, and I'm going to write it over here just so you can see it separately. So let's see if this will work. Let's just work with the one on the left. What is the common factor between these 2 terms that can be pulled out to the left-hand side? Good, we got a lot more people on board. Edgar? Okay, so we could do a negative 16x squared if you want, or we could do positive. Either way, it doesn't matter. Let's try the negative 16x squared. So now what is left? What is left? Dalton?
X plus 1 negative x. Negative 2x.
So we get negative 2x plus 1. Now I'll tell you that ideally we don't really want this to be negative, but I'm going to leave it for a moment because I think Edgar was really trying hard to think through it. But ideally we don't really want this to be negative. Don't worry about it yet. So we did a great job. Now let's look over here on the right and see if there's a common factor that we can find. What's a common factor between these 2? Stephanie? 7 is a common factor, yes. Is there a greater common factor? Valerie? Yeah, 49 is a common factor. 49 is a common factor. So factor it out. And what do we have left? John? Negative 2x plus 1. And now when we put the 2 together, because that's the way it really is, your eyes should be able to identify something. What popped up after we did all this? Something appeared all of a sudden, as if by magic. Davis?
There's 2 common. There's 2 common factors.
Well, think of the word common. Common means the same between both. There's a common factor. Very good. No, that was great. There's a common factor. Negative 2x plus 1. And so now that can be factored out. That can be factored out. That can come over here, and so will that. So we got negative 2x plus 1. And what's left? Matthew? Negative 16x squared plus 49. Any comments, questions, concerns so far? Yes. What was the question? I heard the most of it, but I didn't hear the beginning. Why did I leave them negative? I don't really want them negative at all. I'm leaving it for the moment. We do not want this. I don't have a great explanation as to why, but we want to get in the habit of not having that first term negative. I'm going to leave it alone for the moment because I think Edgar started us off. He was really trying to think it through. And I don't really want to mess up that thought process right now. But in actuality, we want to only factor out a negative if we see that a leading term is negative. If the leading term is negative, then what we really wanted was this to be the negative one that's factored out. This one we really wanted positive. But again, I don't want to mess up. That's not my focus right now. We're going to actually focus on that a little bit later. Okay? My focus right now is trying to find the common factor. So I'm okay leaving it the way it is. All right? Comments, questions, concerns? Okay? So you're going to try it on your own. I do not necessarily expect that you're an expert already. At all. You are going to give it a shot. You try. You try on your own. You work hard. You try to go through the thought process that I'm encouraging you to go through. Okay? So you got 2 questions. You got 4 minutes. That's 2 minutes per question. So it's not a huge amount of time, but it's enough time for you to actually work your way through it. All right, let's see how we did. Part A, what'd you get? Got plenty of confident people. That's what I like to see. We'll start with Valerie, Stephanie, and then we'll go to Kalasia. Okay? You got the same thing, you just switched them around. Kalasia, what do you think? So all three of you got the same thing, and that is correct. Valerie, yours is correct, because you can switch the two factors around. That's not a big deal. Part B was really supposed to be partially easier and partially harder. You just had to have paid attention to something. So we'll start with Dalton, Kayla, and then John.
Y minus 1 times 2, y squared minus 7.
Okay? So you got the same thing, okay, John?
Y minus 1 times 2y squared minus 7.
So all three of you got the same thing, and that is correct. Comments, questions, concerns on either of these? Kayla? That's fine. It's the same thing, but get used to putting the x first. Okay? That should be something that you're pretty good at this point, but just make sure you're putting the x first. Okay? Good. So now we've got all the techniques. We now have all of these. This was the one that we didn't have. Now we can go through the entire process. So now, factoring completely means you factor and you keep factoring until you cannot factor anymore. So you do step 1, then you do step 2. You might have to do all of the steps. You might have to do a couple of the steps. All right. So we start with step number 1. Is there a common factor between the terms of this? Okay, give me a thumbs up if you think you see a common factor between the terms. It's okay if you don't, I'm just asking if you think you do. Okay, I got some people over there think they do, a couple of people over here. Okay, put your thumbs down. Matthew, what do you think the common factor is? 7. Okay, so there is a 7 in common between 14, 77, and 42. Anything else? A greater common factor or anything else? Ziamar? There's also 1x in common between all of them, so the common factor between all of them is 7x. Now we have to put what's left. 7x times, 7 times 2 will get me the 14. X times x squared will get me the x to the 3rd. 7 times negative 11 will get me the negative 77. X times x will get me the x squared. 7 times negative 6 will get me the negative 42. X times 1 will give me x, so I'm done. So, this is a monomial. It's a monomial factor. It's done. There's nothing we can do with that anymore. But this, we might be able to do more with. So now we have to go to the second question, the second step. Let me just put that back up so you see it. We did the common factor. Excuse me. Do that again. We did the common factor, now we need to say, well, is the rest that's left over a difference of 2 squares? Is it a perfect square trinomial? Can it be grouped? Can it be factored at all? Okay? So, we're looking at the green highlight. Is it a difference of 2 squares? Give me a thumbs up if you think that's a difference of 2 squares. Well, it should be obvious that it's not, because a difference of 2 squares means it's 2 terms. Is that a perfect square trinomial? Give me a thumbs up if you think it's a perfect square trinomial. How do you know it's not a perfect square trinomial? Can someone describe how they know it's not? John, how come it's not? Well, that's true, but that doesn't have to be true for it to be a perfect square trinomial. Stephanie? Yeah, all you have to do is look at either here or here. If one of these is not a perfect square, then it's not a perfect square trinomial. Very good. Can it be grouped? What would have to be true for it to be grouped? Caleb? It would have to be 4 terms. Very good, Caleb. So that can't be grouped. So now the last question is, can it be factored at all? Well, what do we do if we can't use any of the other techniques? The trick. So now that's our last resort. The trick's now the last resort. We do all the other stuff first. So now let's try the trick. A times C, negative 12. 2 numbers that multiply to negative 12 that add to negative 11. What are the numbers, Valerie? Negative 12 and? Very good. Negative 12 and positive 1. What's the next step in the trick? Next step, Edgar? Very good. Put them both over A, which in this case is 2. And what's the next step in the trick? Janae? You said that beautifully. Simplify. What will this become? Danielle? Negative 6 over 1. You need that 1 because it's a trick. And so now the denominator becomes the coefficient, the numerator becomes the number that goes with it. So now watch. The 7x doesn't disappear, that stays right there. But this is going to morph into that. This is the coefficient, that's the number that goes with it. X minus 6. That's the coefficient, that's the number that goes with it. Now I've got 3 factors, 7x, x minus 6, and 2x plus 1. I've got 3 factors. I need to double check and make sure nothing can be factored any further. Can that be factored? No. Can that be factored? No. Can that be factored? No. So we are done factoring. That's what factoring completely means, is you keep factoring until you cannot factor anymore. Comments, questions, concerns on that one? I'm pretty impressed. You guys are doing really well with this so far today. This is pretty tough. So now we're going to bring it back all together with the whole purpose of all of it. The whole purpose is to be able to solve an equation. That's the whole point. Factoring is wonderful. It requires intelligence and creativity and thought, and it's good for your brain. But it's kind of a waste if you can't use it to do something. And our purpose is to be able to solve an equation. Remember my analogy. You have a dollar bill and you want to go to the vending machine. You can't use it because the dollar bill's part is not working, so you need quarters. So you make change. You change the form of the money so you can use it. We're trying to change the form of this so we can use it. Okay? This example here, we turned the dollar bill into 4 quarters and then we just left it. That was practice. Now we're going to make the change and we're going to actually use it. Okay? Going through the process again. What's the first thing we're going to do? I turn it over to you. First thing we're going to do. See you tomorrow? Very good. Do they have anything in common? What? 3x. Let's see if there's anything bigger than a 3. No, that only has a 7. So yeah, 3x is the common factor. Now we need to put what's left. And don't forget the equals 0. That's one of the biggest mistakes my students make, is they stop writing the equals 0, and then they forget that they are supposed to be solving an equation. So don't neglect that. Now, what's left over? Anyone tell me what's left over inside already? Kayla's got it, Ziamara's got it, John's got it, Daniela's got it. Daniela, what's left over in the inside the parentheses? (7x squared minus 19x minus 6). Looks good to me. The 3x is a monomial. There's nothing we can do with that. So now we are looking inside at this trinomial. Is that a difference of 2 squares? No, that's not a difference of 2 squares. Is that a perfect square trinomial? Could someone explain why it's not? Why is it not a perfect square trinomial? John? Yeah, and neither is the 7. So it's not a perfect square trinomial. Can it be grouped? No? What would have to be true for it to be grouped? Huh? There would have to be 4 terms. There's only 3 here. So that leaves us with what? Where are we at?
The trick.
The trick. So now we're going to do the trick. A times C, get negative 42. 2 numbers that multiply to negative 42 and add to negative 19. What are the 2 numbers? I hope you're right, because I don't know what they are. Andrew? 21 times negative 2. 21 times negative 2 equals negative 42, but that unfortunately equals positive 19. Okay, so if we take this negative and pop it over there, then it will work. Very good. What's the next step? Next step, Chris? Good. Put them both over 7. And Janae helped us last time simplify. What will the negative 21 over 7 turn into? Michaela? Very good. Negative 3 over 1. This is going to say 2 over 7. Ooh. 2 over 7. And now we've got the 3x doesn't disappear, but we morphed this into this, and don't forget the equal 0 because we have to do something with that. Now we're putting this in here. X minus 3, 7x plus 2. But now remember, we are being asked to solve. You actually learned how to solve this in 9.4. We did a question just like this. What do I have to do now to solve this? 3 people can describe, 5 people can describe. 6 people can, 7 people. Okay, 1/3 of my class, that's good. Stephanie? Okay, you got most of it. What's she missing? Dalton? Well, no, hold on. We're not ready for that. She said set x minus 3 equal to 0. That was right. 7x plus 2 equal to 0. That was right. But we missed something. What did we miss? John? Yeah, you have to do this one too. 3x has to be set equal to 0. How many times will the graph of this cross the x-axis? Ziamara? It's going to cross 3 times. We have to find 3 solutions. If we don't do this part, then we're only going to find 2. But guess what? We already know what the solutions are, right? Because we're super high level bright. What's the solution to this one over here? That one, everyone knows that one. 0. So x equals 0. We already know this one because we've learned a little shortcut. Dalton? It's going to be 3. And we already know the other one because we know a little shortcut. What's the last one? Kayla? -2/7. But you got to pay attention to details. If you forget the 0, then you didn't do your job. So we get 3 solutions. Any comments, questions, concerns so far? Michaela? Does anyone remember what it looks like? I thought I showed, maybe one of my classes my computer stopped working. Did it work for you guys? Remember what it looks like? What did it look like, Davis? Yeah, it was like a sideways S. It goes something like this, or it might be, it could be like that. Okay? And the 3 spots where it crosses the x-axis is going to be 0, 3, and -2/7. So let's see, it'll be 3, 0, and then -2/7. Somehow like that. Okay? Good. Comments, questions, concerns? Okay. You guys are doing a really good job. You got one last one. Stick with me on. Now I want to factor this one. So we're not solving. So make sure you're picking up on this word here. Factor means just tell me the factors. Solve means tell me the solutions. So, go through the sequence. What's the first thing we're going to do every time from now on for the rest of our lives? First thing we're going to do, Michaela? Okay, is there one? There is not. There's no common factor, so good. Check that off, we're done. Is it a difference of 2 squares? No. Is it a perfect square trinomial?
Yes.
Okay, let's see.
No.
Let's do the PST test. First term is a perfect square, last term is a perfect square, but then the test is take the square root of this, multiply them together and multiply times 2, that equals 2. It's supposed to equal 2 there. So this is not a perfect square trinomial. You got to be able to do that PST test mentally in your head. You got to know what it is. So this is not a perfect square trinomial. Can it be grouped? Can it be grouped? Okay, cannot be grouped. Feng, how come? We need 4 terms. Very good. So, where does that leave us? We've been through this before. Where does that leave us? The trick. Very good. So, let's do the trick. So, let's do a little side trip over here. The trick. Multiply A times C. A times C is -1. I need 2 factors of -1 that add to 3. What do you mean?
-1.
Well, wait. We could do...
It's already. Unless you.
It's already factored.
It's already
completely
factored.
So there's no numbers that will work?
No.
1 times -1 adds to 0. That doesn't work.
You know.
So there's...
You know.
Yeah, of course I do. Okay, so the trick doesn't work. The trick doesn't work. So where does that leave us?
It's
Well,
already factored.
there's nothing we can do. But what if I said you had to solve this? Like, what if I probably should have put this. What if I said, you got to tell me the solutions? Does anyone know what you do?
Write it on.
Does anyone know what I'm going to pick up?
Yay!
Quadratic formula.
No.
Yay.
So now you're getting a little clue into what all the letters mean, right? This is A, this is B, and this is C. X is the solution. X equals negative B, the opposite of 3, plus or minus the square root of B squared. 3 squared minus 4 times A times C, all over 2 times A. So that's what this is for. This is for the times when you can't do anything else. Okay? Good. You guys are doing a great job. So, let's check point number 2. Back to the expression completely. Alright, so let's see how we did. We've got a bunch of people still working through it. Okay, hold on, let me survey. Give me a thumbs up if you have an answer. 3, 7, 10. Okay, put your thumbs down. Give you another 30 seconds. My students who are already done, be patient. All right. What'd you get? I had 10 people a little over 30 seconds ago. I got 5 people. All right. We'll start with Davis, Danielle, and then Valerie. How do you know? You didn't even try. Okay. I'm sorry? Okay. Okay, so we got some very different answers. The correct answer is 3x squared times 2x plus 3 squared. So Danielle, you went ahead and then solved it, but you also made a mistake along the way. Yeah, but you actually made an even bigger mistake that you don't even realize, and a whole bunch of the students in the class are going to be wowed. So let's start with the 3x squared. Give me a thumbs up if you got the 3x squared. Good, put your thumbs down. So let's do that first. Let's take the 3x squared out, and let's see what we have left. Did anyone feel confident that they have the correct expression left? What's left, Extol? 4x squared plus 12x plus what?
9.
That is correct. That is what's left. This cannot be factored any further, so that's done. So now we look in here. And now you're going through the sequence. Did the common factor, so the next question you ask is that a difference of 2 squares? Is that a difference of 2 squares? Is it? No. Yeah, difference of 2 squares. There would only be 2 terms. Is that a perfect square trinomial?
Yes.
Yes, it is. It's a perfect square trinomial because it passes the PST test. This is a perfect square. That's a perfect square. The square root of this is 2. The square root of that is 3. 2 times 3 is 6. Times 2 is 12. That's a perfect square trinomial. And it factors very easily into this. Square of the first term, the square root of the first term, square root of the last term, whatever symbol is here goes here. Then we have the 3x squared out front. That is it. Now, if you used the trick, it would still work. 4 times 9 is 36. 2 numbers that multiply to 36 that add to 12. What are the 2 numbers? Dalton? 6 and 6. Put them both over A. But you notice it's the same thing. Reduce 3 over 2, 3 over 2. You get the same expression twice, it still gets you this. Comments, questions, concerns? I'm sorry? I just didn't hear the beginning. You're doing both. 2 numbers that multiply to this, that add to that. Yeah, it's hard. Okay? Comments, questions, concerns? All right, so now we're going to get some more practice. Draw a line across your... Oh, I'm sorry. So here is the list again of things that you are supposed to do. So you should have this down. I don't want you to copy it right at the moment. I don't want you to copy. Don't worry. Okay? So draw a line across your paper. Your classwork is on page 99. You're going to do number 33, which has a number of steps to it, a number of parts to it. Number 29, number 26, 23, 21, 11, and 6. All right. Excuse me. All right. Let's see how we did. Number 33 had a number of parts. Part A. Everyone should have gotten part A. Part B is kind of a new question. Not sure if you knew what to do with that. We'll find out in a couple minutes. Part C. Same as part B with different piece of information. See if you knew what to do with that. Part D. Number 29 is 4/3. 26 has two solutions, -5 and 5. 23, you are asked to factor. Two factors are x squared plus 5 and x plus 1. 21, you are asked to factor. There are three factors, 4z, z minus 2, and z plus 1. For 11, you were asked to factor. T squared minus 2 times t plus 12. And number 6, you were asked to factor. 3 times, one factor is x minus 2, the other factor is y plus 4. So let's start with number 33. Give me a thumbs up if you got all parts of it correct. Good, that's to be expected. What were you supposed to do in parts B and C? Anyone have an idea? What were you supposed to do? Four people have an idea? John? Well, let's just do B. What were you supposed to do with B?
I got it wrong, but what I did was 12 divided by
Okay? So you didn't know what to do. You tried something, and that's good. That's better than doing nothing. But you weren't sure what to do. Okay. Chris?
Substitute T for
Yeah. What does T stand for?
time.
And what piece of information are you given? Time. You were supposed to take the point 1, plug it in for T here and here, and then simplify the expression, and you get 5.04 feet. Part C, you were supposed to take a quarter of a second, plug it in place of T here and here, simplify the expression, you get 6 feet. What about part D? What were you supposed to do for part D? Edgar? Yeah, you were supposed to put 0 here and then solve the equation. Because now we're looking for the amount of time. How long will it take for the birdie to reach the ground? 1 second. So I'm not saying this was easy in any way, but having no recognition of what to do is an issue. Also, nobody raised their hand and said, Mr. Gallo, can you help? Nobody discussed anything with anybody saying, hey, do you know what to do for part B? So John did something. I appreciate that he tried to do something. That's good. And randomly trying to do something when you're not sure what to do is fine on the test. It's fine if you're at home doing your homework by yourself. But if you're near people who are working on the same thing as you and it's not a test and it's not a quiz, then why wouldn't you try to engage with somebody to try and figure out what's going on? So that's going to improve. So next time, that's not okay. This is classwork time. This is time to learn, not just sit there and just do something random. So we need to improve that. So I went over number 33. Are there questions on any of the other ones? Okay. Your homework is on page 628. You're going to do numbers 14 through 56 even, and you're going to do 68 and 70. And that's a total